Okay, here we are. Here we go again. In this video, I'm going to talk about the Norton equivalent circuit, which is the dual of the Thevenin equivalent circuit. In other words, they're pretty much the same. And I'm going to show you why in a little bit. So, as always, let's start with a circuit. So our circuit this time is going to be the following one. We're going to have a voltage generator, and then we're going to have a resistance and another resistance here. Um, this is a node, and then we're going to have another resistance here, and this one is going to be called A, this end, and this other end is going to be called B. Here in between, we're going to have a resistance, which we're going to call R. Well, I just call them R1, R2, R3, and R4. And this one's going to be plus minus V. So, in this case, the problem is saying for the circuit below, we know V equal to 12 volts, Ri equal I ohm, which basically means that R1 is 1 ohm, R2 is 2 ohms, R3 is 3 ohm, R4 is 4 ohm, and so on and so forth. Okay, we only know those two things. Find actually, yeah, just find the Norton equivalent circuit at AB. So between A and B. Okay. So in order to do this, I'm just gonna consider the circuit in a slightly different way. I'm just gonna consider the circuit as if it was closed. So basically, as if all this was closed. So between A and B there was just a wire, and I'm gonna be trying to find the current between A and B in this handle, like as if there was a wire here. So I'm just gonna show you what I mean. I basically mean this. I mean that I'm still gonna have my voltage generator here. I'm gonna have my resistance here, another resistance here. This is a node, and then another resistance here, and then I'm gonna have A. But note here between A and B, I'm gonna have just a wire. Okay, this is gonna be my point B. So this is still gonna be A, this is still gonna be B, but now what I'm looking for is this current flowing through here, which I'm gonna call I of N, or I of Norton. So the Norton current. And of course here in between there is the resistance R3, just like before. Okay, so this is still my plus V minus, it's still my R1, it's still my R2, still my R3, still my R4, and of course I cannot find IN like straight just like this, but I'm gonna have to find a few things before. The first thing that I'm gonna, well, let me just define this as I, which is basically the I total, okay? So first thing first. Right now, I'm gonna try to find Rn, so basically the resistance, the Norton equivalent resistance, which, as I said, is the Norton is a dual of Thevenin, so it's the same as saying RTH, just like in the former video. So it's pretty much the same as finding the Thevenin resistance. So if you remember from the former video, in this case, the circuit is slightly different, but it's it's the same. How you calculate it is the same. So basically, we're going to have R1 plus R2 all in parallel with R3, and then plus R4. Okay, so we're going to have, as I said, R1 plus R2, okay, plus R2. Those two are in parallel with R3. And then plus, we have this other one, so plus R4. So now, if we plug numbers in this, we are basically going to have R1 plus R2 parallel R3, so basically 1 plus 2 parallel to 3, and then plus 4. I didn't write Rn equal to, yeah. So Rn is going to be 2 plus 1 is 3, parallel to 3 plus 4. So Rn, 3 parallel to 3 will be 3 times 3 over 3 plus 3. And I have a plus 4. So Rn is equal to 9 over 3 plus 3 is 6. Everything plus 4. So Rn, should I simplify it? Well, doesn't matter because I'm gonna use fractions anyway. So 9 over 6 is actually 1.5 plus 4, it will be 5.5. So it will be, as I said, 1.5 plus 4. So Rn is actually gonna be 5.5 ohm. Okay, now I also want to find the total resistance, which I'm going to call RT. So RT, in this case, is going to be R3 parallel to R4 plus R2 plus R1. So I'm going to have R3 parallel to R4 plus R2 plus R1. And again, plugging numbers into this, we will have 3 parallel to 4 plus 2 plus 1. So RT is actually, well, it's 3 times 4 over 3 plus 4, plus 2 plus 1 is plus 3. So RT is actually 12 over 7 plus 3. So RT will be, well, 12 over 7 would actually be, well, 1.71. So I will just go with 1.71 plus 3, which is going to give me ounce plus 3, 4.71. There we go. So 4.71 ohms is the total resistance. So now I have everything I need to find I. So this I here, aside from the I of n. So I'm just gonna find I, and I'm gonna find I of n. So I of n, well, actually I, if you still remember the Ohm's law, it's just gonna be the voltage over the total resistance. Okay, so I, they're gonna be the voltage, so 12 volts over RT, the total resistance, which is 4.71. So 12 over 4.71 is roughly 2.54 amps. So now I can find I of n, which is just a subset of the I. So I of n, totally going to be I times R3 over R3 plus R4. So it's going to be R3 over R3 plus R4. So there we go. So I of n is going to be I, so 2.54 times R3, so 3 ohm, over R3, so 3 ohm, plus R4, so 4 ohms. So this is actually going to give us I of n equal to 2.54 times 3 over, well, 4 plus 3 is 7, so just over 7. So I of n, I'm just going to use my calculator now because I'm lazy. I'm going to find times 3 over 7. So 2.54 times 3 over 7 is 1.08. So yeah, 1.088. Well, yeah, I'm just gonna go with 1.1 amps. Approximately. So yeah, that's pretty much it. I can just write the Norton equivalent circuit. So the Norton equivalent circuit is going to be given by this generator of current over here. Then this one is going to be my end A. This one is going to be my end B. And here in between, we're basically going to have our R of n, and I'm also going to have this one, which is going to be our I of n. Okay, so yeah, that's pretty much it. That's pretty much it. This is the Norton equivalent circuit. So now I'm pretty sure you can see why it's called the dual of the Thevenin equivalent circuit, which is we did exactly the same thing for Thevenin, but we had the voltage generator, while in Norton we had we just had the current generator. So they're pretty much the same. Both are equivalent circuits, which we can find and calculate. And just Thevenin is with the voltage and Norton is with the current.